Welcome to audio slide presentation. My name is Jianjun He. I am from DSP Lab, School of Electrical and Electronic Engineering, Nanyang Technological University, Singapore. In next 5 minutes, I will give you a quick look on our paper, Linear Estimation-Based Primary Ambient Extraction for Stereo Audio Signals, published in IEEE ACM Transactions on Audio, Speech, and Language Processing, February 2014 issue. In 3D audio or spatial audio, we aim to create an immersive listening experience of being there in the scene for the audience. There are two critical elements to create the immersive experience. One is the ambient sound, which tells you where you are located. The ambient component is essential to create a faithful sound environment. The other is the primary component, which causes your attention and directs you where the sound of interest comes from. It is important to create a virtual situation similar to what the character is facing with in the scene. Together with the primary and ambient components well reproduced, we listeners can thus enjoy the beauty of sound in the movies and games. However, the existing audio formats like stereo signals do not store primary and ambient components separately, which necessitate the primary ambient extraction or PAE. Recent years have seen the incorporation of PAE in spatial audio processing, spatial audio coding, audio remixing, and their applications for spatial audio reproduction over various playback systems, including stereo and multi-channel loudspeaker systems, headphones, and even hybrid loudspeaker systems consisting of parametric loudspeakers and conventional loudspeakers. In this paper, we study PAE for stereo signals. The stereo signal model states that the primary and ambient components are linearly mixed together with several key assumptions. The primary component is correlated, while the ambient component is uncorrelated with a balanced power in two channels. Furthermore, the primary and ambient component are uncorrelated with each other in both channels. Based on the model, two key parameters, primary panning factor and primary power ratio, can be derived, which are very useful in our analysis and evaluation. Motivated by the linear mixing signal model, we address PAE based on a linear estimation framework, where the extracted components are expressed as the weighted sums of the input signals. With this framework, we convert the PAE problem into the problem of estimation of weighting matrix W. Following the linear estimation framework, we analyze the extraction error and find that it comprises three parts: the distortion, interference, and leakage. To evaluate the performance of PAE approaches, two groups of measures are considered, where the measures for the error components are considered for the extraction accuracy. On the other hand, three most widely used spatial cues, interchannel cross-correlation ICC, interchannel time difference ICTD, and interchannel level difference ICLD, are considered for the spatial accuracy. Based on the linear estimation framework, four approaches can be proposed and their solutions obtained by different criteria. PCA minimizes the correlation between the primary and ambient components. Least squares minimizes the overall extraction error, while minimal leakage least squares and minimal distortion least squares can minimize the leakage and distortion respectively. Some interesting relationships among these approaches are discussed. After that, the performance of these PAE approaches are evaluated in terms of the two groups of measures. Results show that the performance of these approaches is consistent with their objectives. Where none of these approaches have dominant performance for all the measures, a trade-off approach, adjustable least squares, is proposed. By adjusting the value of beta, adjustable least squares can achieve the minimal distortion and minimal error accordingly. The relationships, differences, and the performance derived from our objective analysis are verified in the experiments in this paper. Guidelines regarding the selection of the PAE approaches for different applications have also been provided. In conclusion, we studied the problem of primary ambient extraction for stereo signals in this paper. Motivated by linear mixing signal model, we formulated the linear estimation framework for PAE. Based on this linear estimation framework, we introduced two groups of measures to evaluate the performance of the PAE approaches, including the extraction accuracy and spatial accuracy. We found that the existing approaches like PCA and least squares can be generalized into the linear estimation framework. With some more practical objectives, we propose three approaches based on the linear estimation. A comprehensive comparison and evaluation of these approaches have been conducted in this paper. Based on the advantages and disadvantages of these approaches, we can employ different approaches in different spatial audio applications. For more details on this paper, please refer to IEEE website. Thank you.